Carbon capture is a technology that does, well, sort of what the name suggests. Grabs CO2 before it gets released into the air or captures it from the air and stores it. It sounds like a simple solution to a complex problem like climate change, and it's especially appealing for a country like Canada with ambitious emission reduction targets. But does it work?
It's a good question, and it's probably the question that I get the most as well. The answer is yes, but it's not magic.
That's our guest today, economist John McNally.
There are limits and there are technical and practical challenges that we run into when we're trying to do some of this stuff.
And one of those practical challenges, a big one, is cost.
Carbon capture projects tend to be quite expensive. It's important that we think about ways to bring the technology costs down, because if we don't find ways to do so, then meeting Canada's climate targets could be more expensive.
John is the Senior Advisor for Climate and Socioeconomic Policy at Scotiabank, and he recently wrote a report on the potential and limitations of this technology. He'll tell Armina Lagaya about why Canada is already poised to be a leader in carbon capture, utilization, and storage, as well as the hurdles in terms of implementation and what might be on the horizon. I'm Stephen Maurice, and this is Perspectives. Now, here's Armina Lagaya.
John, welcome to the show.
Thanks for having me.
So we'll get into the details in a moment, but very briefly, what is carbon capture? How would you explain that to someone?
Carbon capture is a chemical process that we use to extract carbon dioxide molecules from air. The term often gets used to refer to two separate ways that we would remove carbon dioxide. The first one is by taking the molecules out of a smokestack or an exhaust vent from a large industrial facility. And the second one is what we call carbon dioxide removal, which aims to pull those molecules out of ambient air, so it sucks it right out of the atmosphere.
So taking technology to be able to take the carbon out of the air or from a source where it would be emitting it into the air like a plant, and then storing it or using it in some other way.
Sometimes it's technology. Sometimes we just take advantage of the natural systems the Earth already has for storing carbon. One of the most common ways of getting carbon out of the atmosphere is planting trees. Oceans tend to be really effective sinks of carbon as well. So sometimes we build large industrial facilities, and sometimes we can simply go out and take advantage of a lot of the systems the Earth already has for some of these processes already.
So there's obviously been a lot of talk or increasing talk about carbon capture. Why don't we start there? Why is this important? Why is there so much talk about this right now?
I think each kind of carbon capture is probably attractive for its own sets of reasons. The first kind, where we plug it onto industrial facilities, the main reason that's interesting is because it offers a pathway forward for us to meet our climate goals while simultaneously taking advantage, or rather maintaining, a lot of the industrial output that is so valuable to modern life. There is a lot of heavy industry that produces goods like cement and plastics and petrochemicals, where using large carbon capture facilities can be a way to ensure those remain climate aligned. Simultaneously, there's also a lot of interest in helping remove carbon from the atmosphere because, well, frankly, there's a lot of it up there. And as we start thinking about meeting our climate goals and keeping the world within temperature thresholds that are set in international agreements, we want to make sure we're able to draw down enough that we can keep the world at the temperature that we want over the long run, which likely means building a lot more carbon dioxide removal in the years and decades to come.
We've talked about capturing it. I want to delve a bit more into what you do with it.
So the way that carbon dioxide gets captured will have a big influence on how it gets stored. So if it's captured by photosynthesis from a tree, for example, then it'll get taken down into the tree itself and it'll get used to produce leaves. But when we're talking about a large industrial facility that's sort of taking CO2 down, a lot of the time there are sort of chemical filtration processes that we'll use. And I'm an economist, not an engineer, so I don't know that I can go in depth as to what some of those are. But once you sort of go through that process, what you'll end up with is a captured gas that can be compressed and transported, much in the same way that you can buy propane tanks, which are sort of filled with this compressed gas. In some cases, those end up being stored underground, because for a big industrial facility, ultimately the goal of this is to get CO2 out of the atmosphere and hopefully not have it be re-emitted if we want it for climate reasons. So oftentimes what we'll do is take that CO2 and inject it deep underground. And that can fit into an empty oil well or some salt caverns or aquifers that happen to be underground. Those are generally fairly deep. Or you can take that and simply aim to use it as an industrial input for some future process. Right now, more CO2 that is captured globally gets used rather than stored. And about 90% 90% of carbon dioxide that gets captured globally goes into two functions. One is oil production. So you can insert carbon dioxide back into the ground with a near-empty oil well to help add some pressure because it helps get some additional oil out. That process is called enhanced oil recovery. And another one is for producing fertilizers. So there are a lot of uses, and they also dial all the way up to if you crack like a can of pop, the carbonation that comes out is carbon dioxide that wasn't necessarily captured from sort of a large industrial facility. But there are a lot of uses for these kinds of products, and they're everywhere that we see in the world today.
So just trying to get my head around this a little bit, what do these carbon capture facilities look like, or carbon removal facilities look like? How do they work?
Some of them aim to remove the carbon dioxide molecules before something is combusted. There's also versions where you more or less take the gas that comes out of an exhaust vent and you pass it through a process at the end that can help sort of extract some of the CO2 that's then reheated and stored in a very, very compressed space. But for a major carbon dioxide removal plant, which tends to be called direct air capture, you look at taking a lot of the ambient air in by sort of sucking it down out of the air, going through a chemical process to sort of extract some of those CO2 molecules, and then either transporting it off-site to a storage location where it can be injected deep underground, or injecting it deep underground on-site. One of the beauties of direct air capture facilities is it can be built on top of really great geological storage potential, which means that you can build them wherever there happens to be clean, low emissions energy and geological storage, and then inject it right underground from there.
And does Canada, from a geological perspective, have an advantage in this way?
We do, actually. Canada has an enormous amount of geological storage potential, and it tends to be concentrated in the western provinces in particular, which are also the provinces where there are a lot of heavy industry emissions from sectors like oil and gas and petrochemicals. And so there might be a good match there for thinking about how to capture some of these emissions and then put them underground in provinces like Alberta and Saskatchewan.
So let me ask the question that maybe some of our listeners might be thinking. Does it really work? It seems so simple. Hey, yeah, sure, we'll just take it out of the air and put it somewhere else, or put it to use, or store it in some other natural way. Does this really work?
It's a good question, and it's probably the question that I get the most as well. The answer is yes, but it's not magic. It's chemistry, and it's engineering. And because of that, there are limits and there are technical and practical challenges that we run into when we're trying to do some of this stuff. So a lot of the major industrial carbon capture facilities can capture up to 90% of the carbon that comes out of a particular facility. There is some R&D that shows that maybe you could capture a little bit more, but for now, most of the commercially available solutions get up to about 90%. Now, that's great, but meeting that number means it assumes some practical things like that the facility's running all the time. And you work in any big industrial facility, sometimes there's maintenance, sometimes parts break down, sometimes things need to be replaced. When that happens, the percentage of carbon that you capture is lower. So just one of those really sort of everyday practical challenges. And when you're talking about using some natural systems, again, it's chemistry. So the Earth is really good at moving carbon around in different systems. And trees are fantastic at sucking carbon out of the atmosphere. But when trees die and decompose, that carbon goes somewhere, right? And when the ocean absorbs a certain amount of carbon, then seawater can actually become a bit more acidic, which can be challenging for marine life and for coastal erosion as well. So again, it does work, but it's not magic. And we have to be aware of some of the practical challenges as well as some of the science behind this if we want to make sure that we can use it to its fullest potential.
Now, when it comes to climate change, how realistic is it as a solution? How much of an impact can this technology make?
It could have a really large impact. There's a lot of international studies that show that carbon dioxide removal could be responsible for up to 15% of the path that we need to meet our global climate targets. But the technology is nowhere near at the scale that it needs to be to help contribute to that today. And all the practical challenges that I mentioned are ones that will have to be managed. So to give you a few stats on this, right now, the world emits about 37 billion tons of carbon dioxide each year. It's a big number. The amount of capture capacity that exists globally is around 50 million tons. So it's about 0.1% of the total amount that's needed. And like I mentioned earlier, there is more CO2 that we use rather than permanently store, which means that some percentage of that actually gets re-emitted back into the atmosphere as well. So the math doesn't totally net out on some of these. And it'll be important going forward when we try to meet our climate targets to make sure that the majority of the CO2 that is captured ultimately gets stored underground and taken out of the atmosphere, because that's some of how the math of things like net zero work. We want to make sure that we are taking just as much out of the atmosphere as we happen to be putting in at any given point in time. And that's what most of the big international studies show. Canada could be a little bit better off in this case. Instead of our capture capacity being at 0.1, it's currently at 0.4. So it's still not great, but we know that out to 2030, we're going to almost triple the amount of capture capacity that we have in Canada. So that'll mean that it contributes a fair bit to our overall climate goals sort of by 2030 or 2050. But if we wanted to contribute enough that we remain on track for meeting net zero emissions, then we're going to have to install it at a much faster rate than we're seeing it so far.
I wonder if you can give us a wider perspective here on the state of carbon capture. What is the current global capacity of the ability to take carbon out of the atmosphere?
Right now, if we look at all of the capture capacity that's installed in the world, and that includes capacity to not only capture, but sometimes transport and store carbon as well, it's a little less than 50 million tons a year. So contrast that to the total number of emissions the world gives out, and it's a pretty small percentage. Now, there are only 3 countries that have more than 2 carbon capture and transport and storage projects. And those are the United States, which has the most, China, and Canada. Canada actually has the bronze medal on this. We have 8 active sort of carbon capture and transport and storage projects, but there's a number that have been pledged to be installed out to 2030. And ultimately, we're installing carbon capture at a fairly rapid rate in this country if you look at some of the global trajectories.
And now, how big a role does carbon capture, carbon management play in Canada's strategy to hit its targets?
A fairly large one if you look at some of the projections. There are some third-party analyses that have shown that it could make up some very large numbers in terms of overall contributions for climate change. Like in some cases, it's like a quarter of total emissions reductions in the country. But the important thing to keep in mind is that carbon capture technologies have a role to play when it comes to meeting our climate targets, but it's not a one-man show. There is a lot more that we'll end up doing in order to help drive towards these goals. So some of the federal plans that have come out state that we're going to need carbon capture to grow at some really rapid rates in order to help meet some of the major scenarios or projections to be aligned with net zero. In the case of carbon capture that's attached to a big industrial facility, it's probably going to need to grow by about 5 to 6% each year from 2030 to 2050.
Wow.
And all that assumes that all the projects that have been announced to be built out to 2030 get built so far. And we've already seen some early cancellations, so if there ends up being some additional cancellations, that growth rate will likely need to increase. Now, compare that to carbon dioxide removal projects, and it's likely that those will need to grow at close to 30% year on year from 2030 to 2050, in part because there just aren't as many of them that are active today, and because Canada will likely increasingly rely on a number of those to help offset some of the continued emissions that it might have moving forward when we think about its net zero future.
And what are the biggest hurdles to ramping up carbon capture at the scale needed?
I would say the single biggest hurdle right now is cost. Carbon capture projects tend to be quite expensive. For reference, one of the big numbers that gets thrown around is back in 2021, the Alberta government made a formal ask to the federal government for about $30 billion in financial support to help install 30 megatons of carbon capture technologies. That nets out to about $1 billion a megaton. But when we think about comparing that big number to how much other climate technologies might cost, oftentimes we use a metric called costs per ton, which is to say we take the total cost of a project and we divide it by the number of greenhouse gas emissions that it's set to reduce, and you get a neat little number that shows the cost per ton. Canada's carbon price is a good comparator for this because right now that federal carbon price is about $80 per ton. So ambitiously, there are some developers of carbon dioxide removal projects, these sort of big industrial ones that act like vacuum cleaners to sort of suck carbon dioxide out of the air, process it, and inject it underground, who say that ambitiously, they think they'll be able to reach around $200 to $350 per ton by the year 2040. And that involves some fairly serious levels of innovation and cost declines up until that point. So carbon capture's biggest challenge is ultimately that it is quite expensive. And a lot of the criticisms that get leveled at carbon capture focus on that specifically. The idea that this technology is really expensive relative to other measures, as well as some of the practical challenges that I think I mentioned before. Folks tend to point at it and say that it may not be performing up to its potential. And cost is ultimately a big barrier. We see project cancellation announcements coming out that do cite that high costs have proven to be a challenge in sort of making the economics of these projects work. But ultimately, it's important that we think about ways to bring the technology costs down, because if we don't find ways to do so, then meeting Canada's climate targets could be more expensive. And we might have to consider alternatives that could have some adverse economic impacts that the path of adopting more carbon capture technologies would allow us to avoid.
We've talked a little bit about the criticisms, the high cost. But what about the risks?
I think The biggest risk that comes with adopting the technology is that it isn't deployed at some of the levels needed. Ultimately, to make the math of net zero work, there will need to be a fair bit of carbon dioxide that gets removed from the atmosphere globally. And because of that, there's a need to think really seriously about how to sort of scale and deploy this technology. But another more practical risk comes down to thinking about making sure that carbon ultimately stays underground and out of the atmosphere for a long enough period of time. One of the examples that comes up a lot is we talk about nature-based solutions in the climate space, investing in things like tree planting and forests, which are a critical part of Canada's broader approach to meeting its climate targets. But one of the realities of that is that we have to take into account that things like forest fires can actually be net sources of emissions at the same time as we're planting trees in order to reduce emissions. So we have to make sure that we're very careful about managing these sort of different emission sources and sinks if we want to ensure that we remain on track to meet our overall climate targets and we're getting the math right on these things. We often think about carbon capture as being about just capturing CO2 and then putting it underground. But there's a lot of infrastructure that needs to go into not only transporting the CO2, but also storing it and potentially transferring it to other facilities to use as an industrial input. And Canada has actually thought really strategically about this, or it seems to have at least, because it has over 5 times as much transportation and storage capacity as capture capacity that's expected to come online by the year 2030. And so if you think a little bit about that, it seems like Canada's starting to think about ways that it might be able to install more capture capacity going forward by setting up a lot of the infrastructure that might be needed for this in advance, which is actually a key way that we can lower costs for a lot of these projects, because paying for novel transportation and storage can be a big added cost if you're just thinking about building a capture project. It's cheaper if you could just plug into an existing pipeline.
And taking one further step back, there might be some listeners wondering, why put the effort towards carbon capture and storage rather than, say, focusing on doing things in a way that don't produce emissions that need to be captured?
I do think it's a really good question. The response I think I'd have to that is it doesn't have to be an either or, it can be a yes and. Carbon capture is going to have to play a really key role in this. There are some sectors that are what we call hard to abate, which is to say that they are industries where there are a lot of emissions from industrial processes, and there aren't necessarily obvious technologies for decarbonizing some of these outside of carbon capture. Cement production tends to jump out as one of these examples for a sector where we know there are a lot of emissions attached, and it's unlikely that we'll be able to decarbonize it at scale without the use of sufficient carbon capture facilities. And carbon dioxide removal can play a really complementary role to a lot of those solutions as well. I don't think anyone is suggesting that we put a carbon capture unit on the back of every car with an internal combustion engine. My understanding of the science is that that would not be technically possible or economic in any way, shape, or form. But it does have an important role to play, both for ensuring that the emissions that are already in the atmosphere can get taken out and for decarbonizing a number of these sectors where there aren't necessarily obvious or readily available alternatives and where emissions might be created from the process of making this good or this commodity itself.
Before I let you go, I wanted to get your thoughts on what the future has in store. So looking ahead, obviously we're talking some long timelines here, 2030, 2040. What does the future have in store when it comes to carbon capture?
Yeah, when we think about climate, oftentimes it's sort of an exercise in foresight, thinking a long ways into the future. I think carbon capture's future is going to be a really interesting one to watch. If you look at some of the major projections that the groups like the UN and some UN bodies have come out with, then the size of the carbon capture sector in the next 30 years could potentially be at the same scale as the current size of the global oil industry. When we think about the amount of carbon that we will need to take out of the atmosphere and put into the ground, that is an enormous amount of growth above today's level, which I mentioned is right now capture capacity globally is sitting somewhere around 50 million tons. Scaling it to the point of the global oil industry would mean getting it into the billions of tons, multi-billions of tons in some cases. And so thinking about how that sector can experience that growth means trying to think really hard about the barriers that it faces today, trying to make sure that technology costs can decline at a rapid enough rate that it can actually be built at some of these levels, and then ensuring that every country kind of has what it needs to explore what carbon capture and carbon dioxide removal solutions might mean for them.
Thank you, John, for coming in and breaking down this complex topic for us.
Thanks for having me, Armina.
I've been speaking with John McNally, the Senior Advisor for Climate and Socioeconomic Policy at Scotiabank. The Perspectives podcast is made by me, Armina Lagaya, Stephen Maurice, and our producer, Andrew Norton. For a transcript of this episode, as well as other stories, insights, analysis, and thought leadership, visit our website, scotiabank.com/perspectives. We'll see you next time.